This test is being done around 2300 volts, and we're balancing inductive and capacitive reactances. And right there to the right there in the front, we got a gallon of distilled water in an air core capacity, and behind that then we got a high induction coil. That high induction coil measures to be 230,000 ohms at this 465 hertz frequency, and we know that for every milliamp of conduction then we have 230 volts, so we've got 9.8, almost 10 milliamps of conduction. So we figure we have a 2300 volts across the inductor. Now what we're trying to do then, we got the amperage meters out there showing the branching. The front amperage meter reading 14.9, if that is correct. That's 14.9 milliamps. And the air capacity is only receiving 3 milliamps. And the one in back, the coil, is receiving 9.8 milliamps. And so now, carefully, we're trying to do here, this 2300 volts, hopefully nothing bad will happen then. This is from an alternator with a 50 feet transmission line. Let's see, we got the 2 meters there. And start pouring some water in there. And we're looking at the meter too. You get that. Looks better. So here we go. We got 3.1 milliamp on the left. That's the air core capacity. We got 9.8 milliamp and 14.9 the supply. And we're going then. I always say this stuff's dangerous. I don't know how dangerous it is. We got 10 on the right. Okay, look at there. Let that stabilize out maybe. Virtually no resonant rise of amperage whatsoever. We got 11.5, 11.3. That's distilled water. And so here we're going back to the whole damn problem about it. Meter on the left, which is showing 9.8 milliamps. That should be reading about 0.98 milliamps with a Q of 10. And it surely don't look like it. And then we got 11.5 in the middle, 11.7, very close matching values of reactances, and yet no corresponding reduction of impedance at the input. That input amperage should be way low. Then we got a little bit of sparkly activity then at that 2300 volts across the water capacitor. Seems like any time we find an edge that's sticking up or something. When we first did this with city water, it was sparking out all over the place because of the minerals in the water. So I would assume that that's been improved vastly. No problem. And so we've shown virtually no resonant rise of amperage when the components have been configured as a tank circuit. Though not even a Q of 1 if there is even such a thing. That's the end of this one.